Ingress Controllers. So let's quickly jump onto this. So before we understand Ingress, I would slightly set up a context on the service. I know this is, most of you already know about Kubernetes services, but I'll just give you a brief overview and then we can quickly jump onto the Ingress part. So it's just an abstract way of exposing an application that's running as pods. So let's assume that I have a Kubernetes cluster, and in the Kubernetes cluster, let's say that I have deployed a checkout application as a pod. So as soon as you do that, the container network interface, so you get allocated with an IP address. So let's say that this checkout application or this checkout pod is assigned with an IP address called 172.16.1.15. And then there is one more application called payments. Similarly, it also has another IP address. And for some obvious reasons, checkout has to communicate with payments and to complete the transaction or something like that. So the first thing that it would do is it can connect to the payments using the cluster IP that it is associated with the pod, using the pod endpoint. But the problem with this thing is that Kubernetes, the IP address that generated is dynamic. So for some reasons, if this pod goes down, so next time it would come up with a different IP address. So what happens in that case is, the application, the checkout application, which is trying to talk to the payments, would obviously receive a 404 or some sort of HTTP status code because your payments is on a totally different IP address. So to avoid this problem, you can make use of Kubernetes services. So like we discussed before, it's just a proxy, and so it identifies the required application or the pod using the labels and selectors. So this way, what you can do is you can make use of the service and ensure that you don't have a downtime, or the checkout which is trying to access the payments doesn't receive 404 or not found. So the way you can create this Kubernetes services, so you can create them in predominantly you can do it in these 3 different ways. There are other ways as well, but yeah, these are the most used. So you can do it. You can create a service as cluster IP. You can also create this service as a node port mode, and you can do it as a load balancer service. So let's try to see what happens when you create this service as a cluster IP. So when you do this as a cluster IP, the service IP address or the IP range stays within the cluster. So someone who is trying to access, like if someone wants to access not the payments, but some sort of catalog directly, so the cluster IP wouldn't be accessible. So you cannot reach using this service. And the other way of doing it is, if you want to expose your service outside, you can probably do a node port, load balancer, or Ingress. So before I jump to Ingress, let's see why we need Ingress, because if something can be done without Ingress, then why do we have to go to Ingress? Because I was saying that using node port and load balancer, you can still access your application from outside the cluster. Then what is the point of using an Ingress? So if you create this service in a node port mode, so what typically happens is that you can access your Kubernetes pod or your service using the node port. So the kube proxy, what it typically does is it has a node the port range. So it's in the 32,000 range. So it allocates one of these ports, it binds one of these ports with your service, and it updates the IP tables. I don't want to go into the details of the different kube proxy modes. So let's restrict to IP tables. So it updates the IP tables saying that in the pre-routing rules, that if somebody is trying to access the node name followed by this specific node port, forward the request to the payment service as well, which eventually moves to the payment application. So this way you can access your application from outside the Kubernetes cluster using the node port. But the drawback is that even sometimes your node might also not be accessed from outside, or because this port is I mean, because these ports come in a random range, like you don't know predefined that what would be your node port B. So you cannot expose multiple ports on your firewall. Like you cannot say that my services would be created within this node port range, so expose all of these ports. So that would cause you a problem because you are exposing a firewall on your specific node, and like you are inviting people to get into your Kubernetes cluster. So that is one of the drawbacks as using node port. And the other thing is that, like I told you, using node port, you cannot, I mean, if somebody is not able to access this node range or the node IP range, so you have the same problem as cluster IP, that they cannot actually talk to your Kubernetes service. So the other thing is load balancer. Probably there might be a lot of comparison between load balancer and Ingress more than the node balancer and the, than the node port and Ingress. So load balancer service is typically something that creates an external IP address for you. Let's assume that I have my Kubernetes cluster on AWS, or I'm using Kubernetes managed service of AWS, that is EKS, and I expose my service as a load balancer. So what happens is that the cloud controller manager, the control plane component of Kubernetes, so it creates or it generates an external IP address for you in 2 to 3 minutes after creating your service. And using this external IP address, you can access your service. So now you don't have the problem of the IP address is not in the range, or you cannot access the IP address. So if that is the case, so I have one question here, that if is the load balancer service type, like the one that we are discussing about, is it only restricted to the cloud providers? So I was talking about AWS or EKS. So is the load balancer service type only managed to them, only restricted to AWS, Azure, or any other cloud providers? Or can you also do it on your personal server, or on the bare metal, or in your laptop? So
no, it
there
is
is
not
a,
restricted.
yeah. So thanks, Rishabh. Yeah. So there is a implementation that can do that for you. So previously, or predominantly, it used to be only restricted to the cloud providers. But there is a project, there is a CNCF project called Metal LP. So using this, you can actually install this on your bare metal or on your on-premise servers, and you can expose your service as a load balancer. But you need to do some sort of configuration, and this is still a not a complete project, or it's still in a amateur state. But you can do load balancer type service on your on-premise servers as well. So now the most important question is, if load balancer service type can do the things for you, then why use a Ingress resource? Because I was telling you that using load balancer, you can expose, you get an external IP address, and you can also get an static external IP address, which doesn't change. So in such cases, why you need an Ingress resource? So the reason for that is there are two things. One is, let's assume we are talking about large scale of services. If I have an e-commerce site, and I'm talking about 2 to 300 services that needs to be exposed. So if you want to do that for each and every service, the load balancer type. So what typically happens is that you create 2 to 300 static external IP address, for which you will be charged by your cloud provider, and that could go into huge costs. Instead, you can create an Ingress resource, and if you have a single IP address, like probably you want to manage all your services using a single IP address, Ingress can solve that problem. And the other problem that Ingress can solve is it defines routing for your specific services. Or you can define using Ingress, you can expose your cluster outside, and also you can define routing for your services. Probably you can do host-based routing, you can do path-based routing, or session-based cookie, or because Ingress comes with, I mean, when you create an Ingress resource, there is a Ingress controller which is actually listening to this Ingress resources, and there is a load balancer as well. So you are equipped with a lot of additional features. You get the features of like, path-based, host-based, or you can do web application firewall, or you can do a lot of things which we'll be discussing going ahead. But this is the context that I wanted to set. Like, what is the use case of Ingress? Because if you have node port or load balancer type services, why you have to go for Ingress? So this is the preliminary context that I wanted to set. Okay, so now I'll be talking about Ingress. So I'm not looking at the chat. If someone posted a question or something, probably I can take it at the end. Okay, so this is the, I've just taken this picture from the Kubernetes docs. So if you look at this specific picture to explain what an Ingress is about. So you have a client, you have Ingress resource, which defines the routing rules for your services. So probably you can say that my service can be accessed using foo.example.com, or you can say that I have 10 services and each of them can be accessed on different context paths on one of your website domains. So such things can be managed using an Ingress resource. So what you need to do additionally is, apart from creating a service, you also have to create an ingress.yaml or an Ingress manifest. I'll also show you, so we'll also be doing some sort of demo or some sort of practical exercises to understand Ingresses more. So this is the typical functionality. So Ingress cannot work directly on its own. So if you just create an Ingress resource on your Kubernetes cluster without an Ingress controller, it would be left as an orphan because nobody understands what it is. So whenever you want to use Ingress, you need to create an Ingress controller. There are wide range of Ingress controllers. So you can look for the Ingress controllers, supported Ingress controllers in the Kubernetes official page. So you have, I think you have close to 30 to 40 which are officially supported Ingress controllers, but there are other implementations as well. So what an typical Ingress controller does is, whenever you create an Ingress resource, this Ingress controller would watch for the Ingress resource, and it simply updates or configures the load balancer. So let me take an example to make you understand more. Let's assume that I'm using an Nginx Ingress controller. So in that case, what I typically do is, on my Kubernetes cluster, I go ahead and install Nginx Ingress controller, probably using Helm charts or plain manifests or something. And once I install this Ingress controller, Nginx Ingress controller would continuously watch for the Ingress resources on this specific cluster, and it updates the nginx.conf. Nginx.conf is the place where Nginx updates all its routing details. So along with your Ingress controller, the Nginx application is also deployed. So if it is some other load balancer, then probably if it is an FI load balancer, or if it is a Citrix or any other load balancer, so what their Ingress controller would do is it would also deploy their load balancer along with the Ingress controller. So sometimes saying that some of these load balancers can sit inside the cluster or outside the cluster. So for example, if you are taking the example of Nginx, so Nginx deploys as a pod inside your Kubernetes cluster. So you don't have to do any additional configurations. But for some of these Ingress controllers, which probably I don't expect many people to use Nginx in their production. Some clients might do, but most of them would go for enterprise solutions. So in such cases, the load balancer might not be sitting inside your Kubernetes cluster, because those load balancers might not have a containerized solution, right? So I was working for FI before to this, and so it itself is a very huge load balancer, and it did not have a containerized solution. So FI sits outside your Kubernetes cluster, and the way it can access the resources inside your Kubernetes cluster is using a VXLAN tunnel. So you have to do some configurations before you actually deploy or before you get started with your Ingress controller. So the whole point of saying this is that so the configuration of Ingress controller varies from one ingress to other. I mean, from one controller to another controller. So it might be simple in some cases, and it might be pretty complex in the other cases. So this is a very simple ingress resource, how a basic ingress resource would look like. So there is no host definition, or there is nothing associated with this basic ingress resource. All that you have is you define the kind as an ingress, and this is your API version. So previously the API version used to be extensions, but from Kubernetes 1.21, I believe. So the extensions is deprecated. Now that you can only use the networking.kx.io. And you define the kind as ingress, and then you define inside your spec, you say what is your service, on which port your service can be accessed. Sorry for that. Yeah. So after that, like I told you, with Ingress, you can do host-based as well as path-based routing. So I think we can jump on. So I have some. Okay. So can somebody confirm that you are looking at my timeline?
Yes, we can see your terminal.
Okay. Thank you. Thank you, Ishita. So for the purpose of demo, I got a couple of services running. So there are these are the two services that are running. So now what I'll try to do is that I'll try to show you that. Let's start with a sample, a very simple Ingress resource. Sorry. So this is a very simple Ingress resource, and for this Ingress resource, I just have I just have defined a host, and what I'm expecting from this Ingress resource is that my service, which I've mentioned, which is mentioned as a HTTP-SVC on port 80, should only be accessed if the user provides the host name as foo.bar.com. So here, what I'm trying to do is I'm trying to define the traffic rules for my service. Right. So if it was only a service, you can simply access this service on the service IP address. But what I'm doing with this ingress is that I'm defining some rules for the user to access this specific service. So now let me try to create. Okay, so one more thing that comes to my mind when I have to talk about this is, so if you see this Ingress resource, there is no Ingress class. I haven't defined any Ingress class for this Ingress resource, but the router has assigned, or the Ingress controller has assigned the IP address to my Ingress, right? So the reason for this is because what I've done before to the demo is that this is my Ingress controller, and in the Ingress controller configuration, I simply mentioned that class. So I simply said watch Ingress without class. So this way, what my Ingress controller would do is it would watch for the ingresses which doesn't have any class, or it simply would watch all the ingress resources on the cluster. So if I mention this, if I specify this ingress class as probably Abhishek, then only the ingress resources with ingress class name as Abhishek would be watched by this ingress controller. So why you need ingress classes is basically because you can do multiple ingress controllers in the same Kubernetes cluster. Probably similar Ingress controllers or different Ingress controllers as well. So probably you have a combination of Nginx and HA proxy, or you have multiple Nginx Ingress controllers which are used by different teams. So in such cases, you need a bifurcation for these resources, who has to watch which ingresses. So for that obvious reason, you have ingress class names. Okay, so kubectl get ingress, and now what I'll try to do is I'll say curl. So it says host not found. Ideally, it should have been accessed on this IP address, but it was not accessible. It is not accessible because I did not mention the host name. So what I'll do is in the headers, I'll simply pass the host name as, and now I'm able to access, right? So this is because the rule that I've defined is allow traffic on that specific service, or I'm telling the Ingress controller to only accept traffic if the host name is foo.bar.com. So I just passed it in the headers, and that is the reason why Ingress controller has, it simply allowed me to access the defined service. Now, similarly, you can do path-based routing. So what I meant by path-based routing is that, so the same use case, but now what I'll try to say is that if user tries to access foo.bar.com with context root or with the path as /first, then route the traffic to HTTP service. And if the user tries to access foo.bar.com with path as second, then route the traffic to the MEAV service. So let's see how this works, right? So firstly, let me delete the old one. Now, again, the Ingress controller would take some time to get the IP address. It was pretty quick, but yeah. So now let me try to access the same URL. So now again you would receive 404 because I haven't defined any path. And in the Ingress definition, I told the Ingress controller to only accept when the user is trying to access on one of these paths. Like it should be /first, then okay. .bar.com. Strange. HTTP service. Okay, let me try to access it on second. Okay, probably I think that service might had some issues. Probably I don't know. The pod probably is not reachable or something. Don't want to waste time on debugging that thing. But so if you see now, I mentioned some path, and depending on the path, it sent or it routed the traffic to a different application. So now, how are these things happening? So let's try to look at the logs. So this is the Ingress controller. So the Ingress controller is created in this specific namespace called Ingress Nginx, and because the Ingress controller that I'm using is Nginx, so it updates this configuration in the nginx.conf. So okay, it's too big. Yeah. So if you see here, the nginx.conf is updated with the configuration for foo.bar.com, and it says that if someone tries to access the location on second, then forward the request to the specific service. So this is how the ingress related configuration is updated. So it says if the location is second, then forward the request to service on the specific port. So similar to this, depending upon the type of the load balancer that you're using, if let's assume that we are deploying Argo CD on OpenShift cluster, and for some reason your Argo CD is not accessible. So what you would do is that you would go to the Ingress operators namespace on your OpenShift cluster, and you can watch for the HAProxy logs. Sorry, HAProxy configuration file. So in terms of Nginx, this is the configuration file. And in terms of HAProxy, I don't remember the name, but it should be in one of these similar locations. It should be probably /etc HAProxy, HAProxy.conf. So that is where you would actually debug and try to understand the issue. By so if you remember, probably last week or sometime, we identified an issue that when we deploy Argo CD using an ingress on the OpenShift cluster, the HAProxy was not, the user was not able to forward the or send the request. So that was because the HAProxy did not even identify this ingress resource, and nothing was updated in the HAProxy configuration. So that was easily identified when you look at the HAProxy conf, because there was no entries related to that specific ingress resource. So then we came to know that, okay, probably because of the missing ingress class annotation or something. Okay, so this is the thing. And you can also do wildcards with ingress. So I think this is probably if you're using it in organization, this is one of the most used because, like, for example, you are on google.com or something, then you have slides.google.com, or you have docs.google.com, mail.google.com. So instead of providing for each and every service, this can be for the TLS as well. So in this case, this happens to be a host for the rules. But if we are doing a secure ingress, so you can also provide the wildcards for the TLS configuration as well. Probably in terms of you have wildcard certificate, there is a very good chance that you get a wildcard certificate from your certification authority. So in such cases, you can also provide, instead of creating multiple ingress resources, you can simply create one ingress resource with the wildcard. And when you create such thing, make sure you use the double quote so that you don't waste 30 minutes like me. So if you do the wildcard, you can get ingress. So now let's get the ingress one more time. So let's wait for the ingress to identify. Yeah. So now the ingress controller has identified this specific ingress resource, and it has updated the IP address. So now I can access the same thing. and I can say foo.bar.com, or I can also say example.bar.com. Similarly, I can pass anything in the headers. So it can be any host that is that is succeeded by bar.com. Yeah. So this is about the wildcards. So this is one of the major use cases of non-secure ingress. So we haven't gone to the secure ingresses, but if you're using unsecure ingress, so you can achieve all these things with the static HTTP as well. Like the things that we have seen, you can do path based, or you can do host based, you can do wildcard. And the other thing that you can also do is you can also use basic authentication. That is, for example, you want to say that okay, anybody cannot access my host, or if somebody is trying to curl to the Argo CD, then he should be a legitimate user. So only the ones who have access or authorization to Argo CD can only access my uh, domain. So in such cases, what you can do is in your ingress, you can simply annotate your ingress using the basic auth, and you can say that you can provide this ingress with the list of users who can access your foo.bar.com, or who can access your service. And so in such cases, what happens is that only the users who have access to your website can talk to your service. Yeah, I think if we it wouldn't make much sense to show that as well, because we are running out of time. But the thing is that you can simply annotate the ingresses in that way, and you can achieve the basic authentication. Yeah, if we go back to the slides one more time. So this is all about unsecure ingresses. So we haven't done anything with respect to secure. But so now if you look at TLS, so I think Jan has mentioned a lot about TLS the other day. So similarly, if we apply the same concept to Ingress, so you can do you can basically add security to your Ingress, or you can add security to your services. So there are different ways how you can do it. So in the other examples that we were looking, it was only about HTTP. All the services were on port 80, and all the traffic that we were talking about is on port 80. But what if I want to enable security, or what if I want to make my whole process secure? So the first thing that you can do is you can use a SSL pass-through. So SSL pass-through is a way, basically the entire client to server request is completely encrypted, and your load balancer that is in the between doesn't do much. It just acts as a pass-through, and your request just passes through the load balancer without encryption or decryption at the load balancer level. So what happens in this case is that okay, so this makes, at first this looks very secure, and it is indeed very secure, but there are some problems with this approach. That is, you have the load balancer in between. In some cases, it can be a very powerful load balancer. It can also act as an API gateway, but because you are restricting your ingress to pass through, you cannot take advantage of your load balancer, right? So for example, you have a load balancer that can do web application firewall, or you have a load balancer that can do path-based routing or session-based routing. But if you're doing pass-through, so you have to compromise on all of these features, because load balancer merely act as a proxy and nothing more than that. And one of the other disadvantages is that a hacker probably, instead of client, there is a hacker who is trying to send request to your server, and because it's a pass-through ingress, your load balancer doesn't even look at the packet, or it doesn't even look at the request that is coming to it. And there is a very good chance that load balancer misses the request, and the hacker can get direct access to your server, right? So this is one of the major drawbacks, at least according to me, that you have a load balancer, but because it is not decrypting the packets, or it is not re-encrypting the packet, so there is a good chance for the individual to directly reach, or the hacker to directly pass a malware in the request and reach to the server. And the other thing is that, so this is also one of the important things according to me, that let's assume that you have a service, and during Christmas or during one of your holidays, your service is receiving exceptionally high requests. Probably it's into millions or something more than that. So in such cases, because your service has to take care of decryption, right? Load balancer is not doing anything for you. So every request that is coming to your service is an encrypted request, and your service has to decrypt each of these requests. So because of that, what happens is that your service, you see the latency. So that is what I was trying to say, that because your service has to do a lot of work. So every time a request comes, it has to decrypt the request and it has to process the request. So that is one of the major reasons. Even like if you see a latency during holidays, or when most of the people are trying to access the application, this is one of the reasons why you see the latency, that your service is doing a lot, even though you have a load balancer in front of your service. So these problems can be handled by SSL offloading. So SSL offloading is the one of the other kinds of TLS that you can do with Ingress. So I'm not saying it solves all of the problems, but it solves one of the problem that I discussed at the end. That is, if you have SSL offloading enabled on your Ingress, then decryption happens at your load balancer level, and load balancer sends a plain HTTP traffic to your service. So that way your service is not in the not receiving a lot of load. So it simply receives a request, and it's about the how you wrote your application. So if your application can handle the request, then that's it. If you have used multi-threading or whatever aspects you have followed in your application, then that's well and good. So because load balancer is doing the decryption for you. So at least the SSL kind of offloading is done. But one of the major concerns of SSL offloading, and SSL offloading is highly not recommendable when security is one of your key aspects, because there is a heavy chance of man-in-middle attack. So because your load balancer is simply sending a plain HTTP traffic for your application, and most of the times your load balancer is sitting at the edge of your network, right? So different types of load balancers actually behave in different ways. Some of the load balancers sit at the edge of your whole network. So if your load balancer happens to sit at the edge of your network and it is simply passing a plain HTTP traffic to your application, then you're almost inviting people to get into your application. But if one aspect it has to be better than pass-through, is only thing is it is faster. Like your application latency can be reduced if you can compromise on the security part. And the other option is SSL bridging. So SSL bridging, it is also called as re-encrypt. So there are different names for these things when it comes to Openshift Routes, which I'll be talking about. But if you're doing SSL bridging, so SSL bridging is mostly similar to re-encrypt. Even if you look at the picture that I try to represent, it is almost similar to the pass-through. I mean to say, sorry. So SSL bridging and pass-through are mostly similar, but one of the advantages of SSL bridging is that it does not send the packet directly to the server, but your load balancer does a lot of things for you in terms of SSL bridging. That is, firstly, it would decrypt the packet that is coming from the client, and then it would re-encrypt, right? So what your load balancer does is, every request that is coming from the client, it takes the request, it decrypts the request, it looks into the information of the request, like what is the actual request about? Is there any malware, or is it a legitimate request that is coming to it, or does it have to perform any additional things like path-based routing, or a lot of things that a load balancer can do. So it decrypts the packet, it reads the packet, understands the packet, and it re-encrypts the packet. So before it sends to the server, it re-encrypts the packet, and again it starts a secure channel with your server. So that way both the communications are secured. Your client to load balancer is secured, and your load balancer to your application is also secured. But so this addresses the second pain point that I address here. Like if hacker sends a malicious or a malware request, a request with a malware, in the first case, because it was passed through, it actually landed to the server. But here, because the decryption was happening and load balancer is reading the packet, and if it identifies that there is a malware, it simply aborts the request, or depending on the way that you have configured your load balancer, it can say that, okay, I don't understand this request. It looks something malicious, so I'm not processing or sending this request to the server. So your load balancer can do that for you. It is very secure, but again, whenever security comes into the picture, then you have a lot of things happening. So again, your server has to bear with the thing that it has to decrypt the packet that is coming at it. So every time a request is coming to a server, the server has to take that additional leap, or it has to do the decryption at it. So a simple comparison between SSL pass-through, SSL offloading, and SSL bridging. So if you have to compare all of these things at one place, and if you ask me what you would suggest out of these three, then it's not a straightforward answer. It actually depends on a lot of the aspects. So I try to put all of these things. At least I am. But I mean, when kind of the applications we look at, for example, pass-through is, I mean, you can use it in very less cases. If you ask me, pass-through, because it doesn't take the advantage of the Ingress controller that you're using. The only thing it does is it makes use of your Ingress controller as just a proxy, and it does some kind of load balancing, but only at the layer 4, that is at the TCP level. So if you want application load balancing, and definitely pass-through is not the option, or SSL pass-through is not the option. You can actually go for the SSL bridge or SSL re-encrypt. And if you can compromise a bit at the security, which is again not the right thing to do. But if some of the applications doesn't require security as one of its key aspects, then definitely SSL offloading makes a lot of difference. So if security is not your thing, or you can compromise, or you can accept that, okay, if it is coming from my load balancer, I trust that a load balancer is doing everything for me, and I accept the requests that are coming from load balancer, then SSL offloading is the perfect choice for you. And it reduces a lot of things, like latency can be gone, and yeah. And if you look at the SSL pass-through, like it's costly because of the reasons that I mentioned, but your connection is secure, and it's mostly used only when you require L4 load balancing or the TCP level load balancing. And your load balancer does not do any kind of cookie. It doesn't verify any kind of cookies or anything. And yeah, it is recommended only when, that's why I try to put a star here. It is only recommended in very few cases, whereas SSL offloading is highly unrecommendable, and SSL bridge is recommended. I know, like this slide can put a lot of questions, or many people might disagree with the things that I put here, or there are different views on this specific thing, but yeah, we can discuss on that. And like coming to the routes, okay, I have examples for all of these things, the SSL edge thing, and how you can do edge routing with Ingress, as well as pass-through, how you can do pass-through with Ingress and re-encrypt. So I'll see if time permits, or else we can do it in the next session sometime. And I'll try to put it in the GitHub as well. So if somebody is willing, they can try it. So coming to Openshift Routes, Openshift Routes, the terminology is slightly different. So SSL offloading is called edge termination. SSL bridge is called as re-encrypt termination, and SSL pass-through is called as pass-through termination. But more or less the concept is similar, but the naming convention is slightly different. And if you try to look at the Openshift Routes, there are a couple of things personally that I don't like. That is, you cannot store your TLS certificates in secrets. So what you have to do is you have to put them, for example, the second and the third. If you look at second and third, the edge as well as the re-encrypt. So we are passing the certificates as part of your route itself. So even we do this with Argo CD as well. If you try to look at the Argo CD CRD, so we support all of these fields. A customer can update the Argo CD route with all of these options. But the major problem is that many people don't would not put their certificates inside a route, or they want to store them in the secrets, or by putting them here, they cannot actually store this configuration in GitHub. Like this route with secrets cannot go to GitHub because for obvious reasons. And so this is the issue. I try to put the issue, and why like there are many requests. Many people have been asking about this to support secrets with routes, and the answer for now is that use Ingress. So the proposed workaround is to use Ingress, and yeah, I think that is the reason why many of the customers even today use Ingress over route, even when they are on OpenShift, because ideally if OpenShift supports routes, they should be looking at using routes, but because of these reasons, there are customers who are still using Ingress on OpenShift. Yeah, and okay, so there is one more thing that I wanted to talk about. So, okay. So in terms of OpenShift, what you can do is that if you want to secure your OpenShift routes, so you don't have to create all the secrets by yourself. OpenShift supports something called as service serving certificates. So what you can do is that you can simply annotate your OpenShift service with this specific annotation, and OpenShift comes with a default certification authority, and all those are self-signed certificates, but it can be trusted within the cluster, and it generates a certification authority, and the CA certificate is stored in a config map in the same namespace, and you can mount that into your pod. So with OpenShift, it's slightly easy, but with Ingress, I'll try to show you here. So what you can do with Ingress is that if you want to do secure Ingress, or you want, let me show you an example of its termination. So I've created the client certificates as well as I've created the CA client certificates as well as the server certificates, so that I don't take a lot of time here. And if you look at the Ingress, so this is the Ingress resource, and the way we do TLS with Ingress is that you can simply store it in the secrets. So this is the difference that Ingress gets over OpenShift, that you don't have to have your secrets, or you don't have to save your secrets in the Ingress resource itself. You can simply create a secret and you can provide the corresponding secret. So in the same way, what I've done is I've created the secrets and I've updated the secrets in secrets type TLS. So once I do that, so I have to delete these ingresses because I have some of the names common. So sorry for that. TTL apply. So now the ingress is getting created with edge termination. So what happens is if I have to access the router, if I have to access the ingress controller, then I have to provide or then I have to show the relevant certificates to it. Only then the request is accepted. So like we saw in the previous example, only till the router your traffic is encrypted. So we can simply say curl and I would say I'll simply pass the headers as host and foo.bar.com.
Abhishek, sorry to interrupt, but I think there is another session, and so people are
Sure.
leaving. Yeah, no, just like repeat.
Okay, got it.
You can continue.
Yeah, so I'll just close it in a couple of minutes. So this is how I tried to access the service, but you see that it failed. So I can pass the client certificates and then that would simply pass my request. Okay, because it's a self-signed certificate that I'm using. So now if you see, because I passed the certificates and router can simply accept my request. And so I'm able to access. So I have other examples as well for the pass-through as well as re-encrypt, but probably I'll take it in some other session. Sorry, I was late by some time, so that might be the reason why I went over the meeting.
Yeah,
Yeah.
no problem. Thanks.
So
It was a great session. Yes.
It was really an helpful session.
yeah, that's all I have. Thanks a lot. Do you have any questions on any specific topic that we
I
discussed?
had asked one in the chat, but it's fine. I mean,
Why are so many controller implementations for the same resource type? Okay, that is because you have, so every load balancer feels that they are better at it, right? So Nginx feels that they are the best load balancer. HAProxy thinks that it is the best. And there are many enterprise load balancers. Because there are many load balancers, there are many implementations to the Ingress, right? And everybody is trying to just fight over each other. Like, and so that's the obvious reason.
thanks, Abhishek. Makes sense. It's competition.
Yeah. And even if you look at the implementations also, they are very quite different. So even apart from Ingress and routes, many of these modern day Ingress controllers support custom resource definitions, and they have their own types, like because Ingress is pretty much static, right? You cannot make anything more with this Ingress file, right? So what these people have come up with is they have created their own custom resources. Some of them are called Ingress Routes. Some of them are called virtual services, if you're aware of service mesh. So different people call with different names, and the implementations are also quite different. And yeah, just one last thing that I would say is I showed you one of the drawbacks with route, that if you're talking about route, you cannot secure or you cannot store this routes information in secrets, right? That is with the predominant load balancer that comes within it, the HAProxy. But there are many load balancer, like FI is one of the load balancer where it doesn't even I mean, it allows route to store these secrets in a these TLS certificates in a secret, and it also provides the other ways, like I told you, custom resource definitions, or you can also put them in a different secret name or config map, and you can provide it in the annotations. So that's the reason why different load balancers are there. Like HAProxy is not supporting it, so other load balancing is supporting it. So people move to other load balancer.
Hey, Abhishek, great session. Do you have your examples, your manifest checked in somewhere? And will you
Yeah,
make slides
I'll
available?
I'll put them in my GitHub, and I'll try to put it in the GitOps clubhouse.
Okay, cool.
Thanks a lot, everyone, for taking your time out.
Thanks a lot, Abhishek. Great session. Thanks.
Thanks a lot.